Good morning and welcome to our webinar brought to you by Promess Incorporated. It's the first in a series in discussing industry trends, and today we're going to talk to you about standard products and using them to cut production cost. Just a few housekeeping notes. On the sidebar on the right, you should see a spot for questions during the presentation. We will be answering those questions at the end of the presentation, so feel free to ask them throughout. So welcome. My name is Stephanie Price. I'm a Senior Applications Engineer here at Promess, and with me today is Glenn Nausley, President.
Good morning. If it's 11 o'clock, I always wonder whether you should still say good morning or not.
It's still morning.
Okay. Well, what we're here to talk about today is industry trends. One of those trends is standardization, which we're going to make the argument that process specialization leads to standardization. And we're going to mix in manufacturing cell concepts because we think the two work together really well. Even though standardization is really the focus. But when you add in standardization and manufacturing cell concepts, what you get is flexibility, agility, and cost savings. Stephanie and I were talking about this, and we were kind of talking about the specialization. And you know, I'm one of these, been around a long time, one of these old guys. I've been in this industry now for about 33 years. And when I first started out, I was in the machining industry. But we started talking about it, made me think about a lecture I had from a gentleman, a professor named Leonard Peikoff. And it was a lecture on Aristotle and talking about what a universal genius he was. It's about a philosophy and mathematics and inventor. And, you know, back in his day, they just called him the philosopher. And then you got Michelangelo and Leonardo da Vinci, sculptors and artists and mathematicians and inventors. And, you know, they really were universal geniuses. One of the students in that lecture asked, why is there no longer any universal geniuses? Why don't you see that? And Leonard Peikoff answered it very simply. He said the depth of knowledge is so broad and so deep in each subject that it's impossible nowadays to be a universal genius. His advice to this young student was become a genius or an expert in one subject. That's difficult enough. And this analogy, I thought, fits really well. I remember back in the late 80s, early 90s, a lot of machine builders, they were really expert in a lot of things, but slowly that has kind of gone away because the technology has become so deep.
We don't even call them builders. Most of the time now they're referred to as integrators.
Yeah, exactly.
For that reason.
They're basically taking specialized technology and integrating it. That's true. And so, you know, with the advanced techniques, the advanced controllers, advanced data requirements, and so on, a lot of these things are really, a lot of these technologies are being worked on as specializations by different companies. Again, I came from the machining industry early on, and that was really in the machining industry. The story is to a large extent over. When I was first working in the machining industry, there's a lot of custom machines, transfer lines, down machines. You would have a part to make, and a machine builder would create you a transfer line or a down machine that would make 2,000 parts a shift, and really high quality, and really, you know, worked really well. But when flexibility and other things were needed, and machining centers started to come on the scene, they were being used more and more and more. And now I'm a little bit out of that industry. I work more in assembly industry now than the machining area, but I don't know a manufacturer of machining lines anymore. I can't think of you know, it used to be Lamb and Hewler, Healy, and Cross and all these guys. Machining centers and standard equipment has taken over. So in the machining industry, it's really gone that direction. In the assembly industry, we're moving that way. Promess is a manufacturer of servo electric presses. We've been doing this for about 30 years. And we have quite a number of standard solutions, but more and more we're supplying our workstations or press modules, and we have a variety of them, both for press and torque. And these modules can be tooled up to do a lot of applications. We have a whole variety. We go down from ounces to hundreds of thousands of pounds, but it's moving in that specialization direction that we've already seen with the machining centers in the machining environment.
And like you mentioned, the technology moves so quickly, it's difficult to keep up on everything that goes into an assembly process.
You have special software, special data acquisition, the interfaces, what do you do with the data, and just the knowledge of the machines, the controls, and the process is gotten so deep. Promess also does torquing. What we're really good at is assembly presses and torque testing systems, and that is our expertise. So we're coming up with standard solutions, but we're not the only ones. We have an example here of leak testing. There's a company, we're friends with them, CTS, Cincinnati Test Systems, and they do a variety of things, but leak testing is what they do very, very well. And they have some standard solutions for leak testing. We do work with, we're involved in lines with companies that do other types of fastening and forming and orbit forming and welding, and it's the same story. They're standardizing their equipment more and more. It's the 80-20 rule. Whoever came up with the 80-20 rule was a genius. I mean, it applies so often, and I think it fits here. 20% of applications may need something exotic where they need a custom station or custom machine built. But about 80% of the time, you can take a standard machine, tool it up. Your tooling and your fixturing and stuff is special, but the machine itself can be standard.
Right, and there's a good reason for that, right? When we talk about all the advantages.
Yep. Commonality of equipment, of course, easier to develop processes. The processes are easier to move from the lab to the production floor. Your pre-production lab, if you're using standard equipment, you can move it to the production floor using standardized equipment much easier. Equipment lead time is shorter. Repurposing stations is easier. That is one of the crazy things. In the old days, going back to the machining analogy, you would have a transfer line or a dowel machine that was built to make a specific part or a specific family of parts. And when those parts were at end of life, that was a whole nother problem, which we're going to talk about. But the transfer line was ultimately scrapped normally. When they switched the machining to machining centers, those machines are utilized again. They're repurposed, and it's a huge advantage to using standard equipment. Possible to swap entire stations instead of repairing online. New part models can be more fully debugged in the lab. Again, if your lab equipment matches your production equipment, the transition from pre-production lab to production is much smoother. Low volume production can be done in a lab or in a smaller environment. So our main subject today is the trend towards specialization, the trend towards standardization, which we think is driven by specialization. We are going to be mixing in the assembly cell concept because the two go together so well. So we're going to be talking a lot about that. Using a manufacturing cell concept, you have reduced setup time. Coincidentally, standardization gives you the same exact advantage. Improved machine utilization, ramping production up and down is easier. Station repairs are easier and don't take production completely down. And it can make downsizing production and down to service parts easier too. And all 5 of these are an advantage. These is just a partial list of the advantage of the manufacturing cell concept, but all 5 are also with standardization.
Right. So, and that's the reason why a lot of people have gone to manufacturing cells, is because you have so many of the common benefits as in standardization, which is why, you know, we're firm believers that when you combine the two, you're really looking at the best of both worlds.
Yep. You end up with really a very powerful, a lot of added agility, flexibility, and saving money in the long run for sure. And this is the standardization can happen without the assembly cell, but we're strong believers that the combination of the two really is powerful.
So to really bring that home, we wanted to look at an example of a water pump assembly. And what we're going to do is compare and contrast traditional transfer line with with custom stations versus an assembly cell with standard stations, right? And a few of the things we're going to look at, you know, how do you develop your process and how is the development of the process different between the transfer line and the assembly cell? What's it like when you start up the line? You know, because really there is about a difference between the two of them. And then what line hasn't a station gone down on, right? What about when your volumes change up or down? You get a new part model. How do you handle that? And of course, service parts, right? There's a big difference between those two. So let's start with developing your process. So with a traditional transfer line, hard automation, most of the time the development's done in a pre-production lab, but very distinctly the equipment that's being used in that lab is quite different than the equipment that is used on the line. And this is where you run into a lot of problems.
Yeah, and this is where, you know, if you spend a lot of time going from different plants, which I spent 25 years of my life going from one plant to another, some of the labs are fairly well equipped, generally not with the same equipment they're using out on the production floor though. So any of the development, it doesn't translate directly. You know, you can figure out a lot of things, but you can't figure it out 100%. Some of the pre-production labs are using, you know, World War II vintage equipment and arbor presses. I mean, on the production equipment, they're going to use an electric press, and in their lab, they're doing their testing with an arbor press. It's very difficult to figure, you know, to really prove out a process.
And the problem with that is that now, to prove out the process, you're not going to get to do that until the transfer line is completely built. And that takes time and energy. Many times we even find out that the components aren't sized properly. So you either have a press or unit that's too small for the application.
Or how often have you been working on a project and the machine is built, you're running cycles, and you're running a 30-second cycle time, and they're expecting a 20-second cycle time and want to figure out how to get 10 more seconds out of it because it was never actually debugged on a production type of piece of equipment.
Right, and the cycle time wasn't thought of during that part of the process, and they didn't.
You're using best guess at that point. So we're also part of our advocacy here for the pre-production lab guys. We're on your side. You need to have you know, the standard equipment which is used in the manufacturing area needs to be in the lab.
Right, and here you can see, so once you are using that equipment in the lab, most of your process is debugged in that pre-production lab. You're familiar, you know that you have the right sized equipment. So once you get that cell to your floor, you have very little process development that needs to be done after that.
It's apples. It's apples to apples. If your lab equipment matches your production floor equipment, it'll slide right in. If you're not developing, you can develop the processes really 100% before the production equipment is built. And any transfer line or down machine I've ever worked on, the final process development is either done on the builder's floor in a rush because the machine's late, or the machine is shipped, and then it's done on the end user's floor.
Exactly.
Yeah.
But now your station is all debugged, it's ready, it's on your floor, but guess what? one of them went down. You know, your whole line here is only as strong as your weakest link. And right now, according to this example, your bearing press is down. A custom station, it means specialized knowledge. So if not every person in your maintenance team understands that specific station, you either have to wait until that person comes in or try and find another way to take care of this. But right now, because this is all linear, nothing on this transfer line is running.
Right. Every station is down. Every station behind that station is down, or ahead of that station. Is that behind or ahead? After that station. I'll use the word after.
When you look at an assembly line, or excuse me, assembly cell that's using standard equipment, now, because it's standard equipment, there's more common knowledge and there's less there's shorter downtime.
Yeah, the actual repair should be quicker. And the other thing with standardized equipment, which we'll talk about in a little bit, is generally it's simpler. The idea is to have a simpler station rather than a very complex custom station. So the simpler station should be able to be brought up a lot quicker.
You also have standard spare parts. So you don't have to keep a ton of specialized spare parts.
You could potentially have a spare whole spare station. So if a station does need to be rebuilt or something's going on with it where it's going to take a few days, you can forklift in a complete new station, swap the tooling over, swap the programs, and you're up and running.
Yeah. Right, which is ideal. And then, the volume changes. We know that this happens in the field. This line, for instance, is designed to run 2,000 parts a day, but now you need 2,500 parts a day. Floor space is a premium, and adding a new transfer line for just 500 additional parts isn't economical.
Right, it's not a simple thing to do. If generally you have one or two bottlenecks stations, 75% of your stations could do 2,500 parts a day, but maybe the bearing press can't. So you can add a second bearing press station in, but on hard automation, again, it's not an easy task to add in a station. Where if you have a cell, you just drop in another station.
Right. So on this example, if we were trying to add the bearing press because we want to increase production, we have to take the whole cell down. Well, that's illogical. We're trying to increase it, not decrease. With the assembly cell, we can just simply add the bottleneck station right here and then change slightly the robot so that it knows to use both stations, and then you can get up and running. In the meantime, you're still using the station.
You can prepare that station offline, wheel it in, takes a half a day to get that station up and running because you've got it all set up offline.
And then if you do need to double the amount of production that you have, then you can add another cell. And these cells tend to be smaller in size and take up less floor space than the traditional transfer line. If your volume goes down, right, now your second cell that you had, you can repurpose those for either a new part model or spare parts for a different station.
It's back to the machining center analogy. You bring in machining centers if you need more production. When you don't need them anymore, you take them off. You're making water pumps and your water pump production's going down, but your compressor production's going up. You move the equipment over to the compressor production area.
And then if you no longer need the bottleneck station, you can remove that one as well.
And one thing with the whole ramping up and down, there's a life cycle to a part. We all know you build a machine, it can do 2,000 parts a day, but you really only need 500 parts a day in the beginning, but I got to get this whole line up and running so that I can do 500 parts a day. Usually the machine is limping along and you're getting 500 parts a day off of it, and you're working because it can't do 2,000 yet, and you're working at it to get it up to 2,000, but over a period of time you got to get it up to 2,000, and then hopefully your business takes off and you need to get 2,500 or 3,000, and now you got to work to do that. But as the production changes, a new model comes out or something, you need to start ramping down And the ramp down, again, on a transfer line, if you only need to make 1,000 parts a day, you still got to keep that whole transfer line maintained and up and running that can do 2,000 parts a day. But again, with the cell technology, with standardized equipment, downsizing is easy. You're saving a lot of floor space. But the real big problem is that part, you're totally out of normal production, and now you're going to service parts. How do you handle that?
Right, and we have customers who have kept a line on their floor, taking up space simply to run 500 parts a month.
Yeah, we have worked with customers where they call us and tell us, we run this machine 2 days a month, and I don't want to put money into it, but it's down. Do you have some used equipment? Do you have a used controller? Because they're keeping a transfer line that is old up and running to run it 2 days a month.
Right, and floor space is valuable. Floor space is money, and you have to wonder, is that floor space that they're using is it economical?
And very often they will outsource the service parts. They'll find a company that will build it, will build their service parts, but they ship that company the entire transfer line or the entire piece of equipment, again, designed to make 2,000 parts a day because they need to make 500 parts a week on it.
So let's look at what we could do, with using an assembly cell and standard parts. Okay, so here's our assembly cell, and now we just need to service the parts. You can break that cell up. You can repurpose a majority of that cell and just take the 2 stations that are needed. Since you're using standard equipment, and this is really low volume, you could set up and have your steel press be tooled up to run your bearings, and then change the tooling and have it run the whole process all the way through.
You only need 1 press station to run all 4 press operations because it's so low volume, and you tool it up and you run 500 parts of the one, and you run 2,000 parts or whatever, and you swap it around. And we have many customers that do this. This is not unusual.
Mm-hmm. And that's really, we're talking here, but if you look, the life cycle of a standardized workstation like this, it can go from the production floor to the production lab. It can retool for a new part. It just has a lot of flexibility and agility. And we can speak about this because we do this every day.
And at Promess, we have what we call our PDC, or Process Development Center, and we have our standard equipment, and rarely a day goes by that we don't have someone send us parts, or they bring in parts. They'll bring in some tooling, or we'll put something together for them, and it takes us anywhere from an hour to a half a day to set up to run a part. That's a brand new part we've never seen before. And by the time, we set up the tooling, we program it, we run a few cycles, and normally they'll send us 5 to 100 parts, and we run it for them, and we send the data back to them, or they're here, and we're helping them develop their process. But I mean, I think the point is, though, with the standard equipment is you can change over to a completely new part. Of course, you have to redesign your tooling and your fixturing and stuff. So there's pre-work there, but once that work is done, the machine can be changed over quite quickly. And if you have this kind of equipment in your lab, in your pre-production lab, which actually our process development center, it's really interesting sometimes how it works. We'll have customers that will be coming to us, and they come to us multiple times as they're testing and setting up and having us help them with their process. And the light bulb goes off, and they're like, why am I coming to you? I need one of these in my lab. And that's a lot of times how we start our relationship with customers is getting one of these systems in their lab. But so it's something we do every day.
All right, so we told you in the beginning that we were going to show you how you can cut your production costs. So first, standard equipment costs less than custom equipment, period. It just does.
And the more standard, the more cost savings. The more special, obviously it costs. There's a cost to customization.
Standard machines can be repurposed, and this is really key when you think about it, because now if you have a project and you have 2 projects, you're using standard equipment, the cost of that equipment can be utilized over several projects.
Now you're amortizing it over several projects, and the accounting guys know all the special words for that, but it is one of the key advantages.
Time is money. I mean, we hear this all the time. We've grown up hearing that, right? Less complexity means less startup time. Standard means less downtime. When you have standard equipment, the knowledge is known throughout. You have standard spare parts on your floor.
Everything becomes simpler with standards, and simplicity saves time, saves money.
So let's field some questions.
Dane is supposed to send us some questions, I think.
Dane is on. I don't know if he's going to send us any questions. You did. So the first question I see, my press application requires over 100,000 pounds. Does Promess offer a standard solution at this force level?
Actually, we do. We have a standard solution up to currently 400,000 pounds. To be honest with you, we've only built the 200,000 pound one. Our 400,000 pound solution is only on paper, but we do have a solution on paper. But 200,000 pounds and down, we've built quite a few. And so, yeah, 100,000 pounds is not a problem.
My standard would need to have the flexibility to either be manually loaded or robot loaded. How do I handle this?
You know, really, there's not a lot of difference between manually loaded and robot loaded. The biggest difference is safety. Is how do you handle the safety? Manually loaded, you got guarding, you got light curtains, you got doors, you have to take safety into account. Robot loaded, if it's never going to be manually loaded, and especially if you're not even talking about a collaborative robot, if you're talking about a standard robot that has to have a cage around it, then you don't need any kind of safety equipment around the press, because if there's a cage around the press and the robot, then you can take away the safety equipment. But besides the safety aspect of it, there's not a lot of differences. The only other thing is we do have some control, a synergetic control with robot controllers. So talking to robots via our control is standardized also. And we do have applications where customers do have the exact same equipment that is being loaded via robot, and it's at times manually. And again, it comes down to the safety, the guarding, the light curtains, things like that have to be on it for the manual operation.
Can our workstations incorporate other things like a leak tester?
They can. You can put additional things on it, but the more you do that, the more you're moving away from standardization. I think there's a ton of advantages to not combining the two, letting CTS, as an example, supply a leak test station and Promess supply a press station, and transfer the part between the two. The combination, the one advantage might be throughput. You can, having them both in one station, you can produce parts a little bit faster, but you're also adding cost and complexity and so on. And if throughput's a problem, you might find in the long run it's cheaper to have 2 standard press stations, and maybe if you needed a dual leak test station, rather than combining the two. I mean, it can be done, but you're throwing out a lot of advantages doing that.
Well, it goes back to, now you're asking somebody who's not a genius at something. If you're looking at us, we are geniuses when it comes to pressing. We are not by any means geniuses when it comes to leak testing. If you allow those people who know their processes inside out to handle it, then in the end you have a much better solution. Manual versus robot loaded, what communication standard is preferred?
I don't know if I understand the question, but
I think they're wondering if there's a standard communication between a robot versus our system?
Yeah, well, with manually loaded, normally we're pretty basic. I mean, we would normally, you'd have your e-stop, certain, some home buttons. You've got an HMI where you can show some data and so on, and then you have a cycle start. And depending on whether there's a door or light curtain, there's some subtle changes. But with a robot load, the Promess controller, there is a synergetic link between, we can put a link between the Promess controller and the robot controller so that you don't need a PLC in between. A standard way to do it would be having a Promess controller, a robot controller, and a PLC that kind of links the two. But we can also talk direct without the PLC. And basically, it's just a controls thing where if you're going to load it manually, you turn that link off and you run it with the manual controls. If you're going to run it with the robot, you turn the manual controls off. And for safety reasons, there has to be, that is all handled by a standardized control solution.
And if you did want to use a PLC, we are able to communicate with all the standard protocols, Ethernet IP, Profinet, Profibus. So, what are some of the challenges in developing a standard product that's flexible enough to handle a wide variety of applications?
That is a challenge, and the biggest thing is Promess. Our business, we do have some standard solutions for certain applications, but we also have a variety of sizes. It really comes down most of the time to sizing, and some of our customers will select a couple of different sizes and try to stay, because again, the advantage of standardization, they may select a solution that is good from 6,000 pounds and down, and then another solution that's good from 20,000 pounds and down, and they try to stay within those two solutions just for standardization. You can do on the large presses, you can do they're just as accurate as the small ones. You can do light work also, except in the force measurement. That is the one thing where if you have a system that can go up to 20,000 pounds, it's not going to have the force measurement accuracy of a system that can do 5,000 pounds. It's pretty much a linear equation. The 5,000 pound unit is typically going to be about 4 times more accurate. But besides that accuracy, and that's really the only thing you have to take into account, other than the size of the parts and things like that. And there's different options as far as the size of the beds and size of the equipment. And with some of our customers that buy a higher volume, we make a standard for them. So it's their standard. It's not our catalog item, but it's a standard that fits their application, and that it becomes a standard for them.
So Mike's asking, a lot of these solutions seem to be shown more for smaller assemblies. Are these ideas feasible for larger assemblies where it may not be feasible to move around with a robot, an axle?
Yes. Again, that's one where the special standard, if you will, really makes sense. We do have, most of Promess's standard workstations are geared toward, parts maybe as big as an engine block or a transmission. We do have things like that large, but most of our standards are designed for parts you probably could move around with a robot or even maybe manually. But we do work with customers to develop a standard for them, because really the big thing is, the more you can work with an industry standard, say I'm going to call it a Promess standard, but like with a Promess standard, there is a cost savings there for sure, because the more you can work with a standard, the better. But there's tons of advantages even if you go internal to your manufacturing needs, and you make a standard for your processes and stick with that standard. You don't get all of the advantages with I'm going to call it a special standard, if you will, but you still gain a lot of those standards. So some processes requires a little different twist, but if you can standardize that little different twist, that's perfect. And It's like I said, the 80-20 rule is really an amazingly repeatable over different things. And we do find, 20% of the time, there'll be something that's kind of a little bit exotic about the process, and then it's more difficult for a standard.
Okay, so those are all the questions. Trying to get back to the...
I have to apologize to Stephanie. She kept trying to edge in a word, and I talked too much.
Oh, it's fine. You're a wealth of knowledge. So if there's anything that you saw that you want to talk more about or any of our products, feel free to contact us either by email or telephone. And thank you, everybody, for coming and joining us today.
Thank you very much.